Okay, so should I open this team window or this YouTube? Both. Okay, I'm keeping side by side, no issue. For the YouTube window, I need to see the chat box only, right? Okay. So I'm starting, right? Okay. Very good afternoon. I welcome all the students who have registered with this course, Thermal Engineering Basic and Applied, to this live session today. I shall request you all who are attending this session to post your question in the chat box so that we can discuss your questions, and I will try my best to address those questions through our discussion today. The course Thermal Engineering Basic and Applied, so that this course is an important core course for the students of mechanical engineering, electrical engineering, chemical engineering, power engineering. And in this course, I have tried my best to cover several topics like, applied topics only. Most importantly, I have also tried to discuss about the basic thermodynamics, which is an essential part to understand the operation of several, applied thermal system, thermal device. So I hope you have already completed a few lectures of the course, and if you have any questions from those lectures, I shall request you all to post your question in the chat box. If I can recall, you have already gone through an important module of this course, that is the basics, recapitulation of thermodynamics, and these are very important concepts like the application of first law, combine first and second law analysis. And if you have any questions, or if you didn't understand any particular part of this particular module, please raise your question, or you can write your question in the chat box so that we can discuss them. Students who are registered with this course and attending this course, I shall request you all to raise your question already, those you have, or if you have any particular doubt, kindly write them in the chat box. Learners, students, and okay, so I can see one question. Okay, the question is Mr. Akhilesh Kumar. He is asking the question, I make question based on first and second or SFEE law. I hope you mean SFEE means steady flow energy equation. I get stuck. I want to know from you what approach should we take while making questions, which will be which will help in making question. I do not know because exactly what your question is. Now, you know that I have discussed about first law, also second law, applied to both closed system, that is control mass system, and also for the control volume system. Now, you know, applying first law to a process that takes place across a control volume system, we certainly get a mathematical form. And that form is very important to know exactly, because you know, whenever we will be analyzing any thermal system or any thermal device, it is, you know, very important to know in the paradigm of engineering thermodynamics or classical thermodynamics. Probably you have studied this, you know, important, one of the most important courses in your undergraduate curriculum, that is the thermodynamics. Thermodynamics is a conceptual and, you know, fundamental subject. So to understand exactly the efficiency of any thermal system, efficiency of any thermal device, or to know the heat and work interaction of any particular device, that is for the flow process, of course, we need to know that particular steady flow energy equation. So you need to first know the need of this equation. When can you apply that particular equation? And then you can understand that steady flow. Essentially, you can apply that equation to a control volume system, and then knowing whether the device or system is having heat or work interaction, you can, you know, you can have the quantification of that particular, you know, energy, either in the form of heat or work. Now, I'm getting another question. Explain NPSH. NPSH, basically net positive suction head. I really do not know exactly why you are asking these questions in this forum, because NPSH is very important for the, you know, safety operation of any, you know, turbo machine, in particular pumps or turbines. And in this particular course, I don't think that I have discussed this particular term. So thermostatic expansion valve also, you know, it is you know, if you talk about the refrigeration cycle, therein we have discussed about the throttle valve or expansion valve. And I do not know specifically why again you are asking these questions in this forum. If you are really interested to know this, kindly email me. I will certainly get you back. How can the knock in SI and CING can be controlled? I really do not know whether already, you know, that particular module has been, you know, completed by this time. But controlling the knock in CI and SI engine, first of all, you have to know exactly why knock appears, why knock is getting produced, and if you know the probable reason, then we have to have some remedial measures to prevent the severity of this undesirable phenomenon, that is knock. You know, to some extent, this problematic issues will be there, but our objective should be to minimize the extent of that undesirable phenomenon, that is knock. But it is not so easy to completely minimize it. So knock in CI and SI engine can be certainly, there are many ways by which the knock in SI and CI engine can be controlled. Certainly I will be discussing this part. Probably there are another 2 live sessions remaining for this particular course. Since if I can recall correctly, I had discussed this internal combustion engine part, I think towards middle or end of this course. So I will be discussing this. And again, you are asking question combustion phenomenon both in CI and SI engine. Fine, because you know that it is the course wherein we had to discuss many topics, starting from basic of thermodynamics to steam power engineering, then internal combustion engine, boilers, steam turbines, refrigeration cycle, and also gas turbine cycle. So that discussion, that is the combustion phenomenon, a detailed discussion of this particular important, I should say, process was not possible. But if you again are very much interested to know the combustion phenomenon for both SI and CI engine, I will certainly help you. I can certainly give you some references and you will learn. But you have to keep in mind that SI engine and CI engine combustion, I can give you a brief structure about this particular important thermodynamic process. SI and CI engine, you can understand that internal combustion engine can be classified, or engines can be classified based on the type of combustion. And from the name itself, you can understand that is spark ignition, that is SI engine, and compression ignition, that is CI engine. Now, combustion is basically I should say a complicated process in which thermodynamics, fluid mechanics, and heat transfer. So you have to have basic understanding of these 3 different subjects to understand the combustion phenomena as a whole. Now, why do we need to have combustion? That is the first and foremost question you should have. We need to have combustion because we need to have energy conversion. So we are supplying stored energy, that is chemical energy, that is remaining stored within the fuel, and that fuel, when is entering into the engine cylinder, we need to convert that energy into another of its form. And the way that energy conversion takes place is the combustion process. So the fuel is basically, I have briefly discussed about this particular aspect again. This is, kind of fuels are basically hydrocarbons, and to burn that hydrocarbon, essentially combustion is a chemical process in which, as I told you, understanding of thermodynamics, fluid mechanics, and heat transfer is very much needed. And whether or not combustion has started can be better understood by the appearance of a visible flame. Now, to get that flame, certainly you have to have, some kind of chemical reaction, and that to initiate or for a successful, I should say, as well as an efficient reaction, we need to supply air, because without the presence of oxygen, the fuel that is being supplied to the engine cylinder will not be in a combustible position. So when we are supplying fuel, we also supplying air, and then these two should burn. That is, fuel will burn in the presence of air, rather in the presence of oxygen which is available in the air that was inducted into the engine cylinder. Now you know that for any chemical reaction you need to initiate. So again, thermodynamics is coming into the picture. If the case would have been like this, that the fuel upon contact with air which is freely available in the atmosphere will combust, then it would have been very difficult to have, storage, transportation of the fuel. So certainly we have to have a thermodynamic state, and that state will forcefully allow the fuel of specific fuel to combust or to initiate combustion. Now for the SI engine, that fuel which is not only supplied in the form of a pure fuel, rather it is supplied to the engine cylinder in a mixed with a mixed air. So basically air fuel mixture is prepared, and that air fuel mixture is introduced into the engine cylinder. Nowadays, of course, and to explain it, probably I introduced the need of another essential element, that is the carburetor. But nowadays, you know that carburation is almost obsolete. So there are kind of advanced engine system. But if we consider the presence of carburetor, that carburetor allows the mixture that needs to be supplied to the engine cylinder should be homogeneous and to some extent chemically correct, rather to large extent chemically correct. Now, even that air fuel mixture which is being supplied or which is supplied into the engine cylinder will not take part or will not combust until and unless we are burning them with the help of an external agent, that is the sparking. What that sparking does, basically that sparking somehow establishes a predefined thermodynamic state which is required for that particular specific air fuel mixture to initiate combustion using that particular air fuel mixture. And once the combustion has initiated by the spark plug, this is, I told you that the combustion is basically an exothermic reaction. It is because of this exothermic reaction, the heat being liberated or generated, that will essentially increase the thermodynamic state inside the engine cylinder altogether, and the process will continue. While for the CI engine, so I'm just giving you a brief idea about this, but again I'm telling combustion is essentially a very complex process. There is a specialized paper that is combustion engineering. If you have certain interest, and there are many research articles also available. There are several steps have been taken by the researchers to improvise the combustion process essentially towards the enhancement of combustion efficiency. So just I'm briefly giving you that SI engine combustion, basically that you have to have combustion because the energy which is remaining stored in the fuel, that energy should be converted into heat, another energy, and from there, because heat and work, again we know from first law that if it is a cyclic process, so the net cyclic integral or the net heat interaction between system and surroundings is equal to net work interaction for a cyclic process, of course. So now, so you know that if we can have chemical energy to be converted into heat energy, so from heat we can have another energy, that is work. And if we can have work, so certainly the purpose of designing or developing the engine would be fulfilled. But now for the CI engine, you know that the combustion takes place without a need of the spark plug, because the compression ratio of the engine itself allows the air which was drawn into the engine cylinder during intake stroke to achieve a thermodynamic state in terms of pressure and temperature. That pressure and temperature will allow fuel to auto-ignite when fuel is sprayed into the engine cylinder towards the end of the compression stroke. But eventually, whether we are having a spark plug to initiate the combustion or we are trying to initiate combustion without a need of the spark plug, the idea of combustion is fuel, whether the fuel was supplied to the engine cylinder with air itself, or fuel is supplied separately or fuel is sprayed separately at the end of the intake stroke, or air is taken separately, the basic is same. Fuels are hydrocarbons. We need to burn that. We need to have a certain thermodynamic state or condition, and to burn that fuel we need adequate oxygen, and that oxygen will come from the air or from the supplied air. And once the combustion is initiated, as I told you, whether or not the combustion process has started, that can be better understood by the visible flame. But you know, whether the combustion has started inside the engine cylinder, or you know, flame has got developed, or flame is propagating from one part of the cylinder to the another part or not, because you know, combustion phenomenon, the flame will develop from one part, that flame will travel, eventually enter, you know, charge, that is fuel air mixture will be combusted. But it is very difficult to understand from outside. So what is done essentially, you know, I told you that the onset of combustion can be understood by the appearance of a visible flame. But if it is not possible to look at or to look into the appearance or the visible flame, so basically, you know, we need to know the pressure and temperature that will continuously change inside the cylinder. So by monitoring the pressure and temperature inside the cylinder, we also can have we can have information about whether the combustion process has started or not. So again, I should say that combustion phenomenon in both CI and SI engines is indeed a complex, I should say, phenomena. There are several, you know, processes, and if you need to know combustion engineering itself a separate subject, I should suggest you kindly, if you have interest in this particular topic, very interesting topic I should say, kindly go for, you know, specialized courses on this particular topic. Okay, another question I'm getting, how piston ring work? Okay, this is the question. So you know that piston ring, basically piston rings are provided providing piston ring with the piston, or providing ring with the piston, has a few distinctive objectives. What are those? You know that piston will be having to and fro movement or reciprocating motion between two designated centers. Those are top dead center and bottom dead center, or these are also known as inner dead center and outer dead center. Top dead center is also known as inner dead center. Bottom dead center is also known as outer dead center. So between these two centers, piston will be having continuous movement. So now and the piston will be having movement between these two centers inside the cylinder. The piston wall will be always in touch with the cylinder wall. Piston material is very costly because you know that piston material will be able to withstand that high pressure, high temperature. So certainly, and changing piston is not a very easy and cost-effective, idea. Frequently rather. So to prevent the piston surface not to have any scratch, we need to provide piston ring just to increase the piston life. Also, the piston rings are also, used to prevent leakage, because at the end of the combustion process, the pressure which is being developed on the face of the piston inside the engine cylinder, that pressure should not leak out. Otherwise, pressure will fall. If pressure falls, work output will be less. So that piston rings are provided to arrest or not to have any leakage of the high pressure, high temperature combustion gases through the gap, however small it is, between cylinder wall and piston wall. So another question, in CI engine, why large flywheel is required? So essentially you can understand that efficiency, just I am giving you some clue. Why do you need to have flywheel? Flywheel basically, flywheels are used in the context of internal combustion engine to store or to reserve energy. So when we have discussed about 4 different strokes, we know that there is only one power stroke vis-a-vis 3 ideal strokes. Now we are getting energy or power output from the power stroke, and that power should be consumed by the engine for 3 different other ideal strokes. So we have to have some mechanism so that the power being produced during power stroke can be stored, and as and when required, we can borrow that energy from that particular source and we can supply to the engine cylinder, to the piston or crank and connecting rod mechanism. So basically I should say we will be getting power output or work again in the form of energy available at the shaft. A part of that work should remain stored in a source so that to execute 3 different other radial strokes, the shaft will be getting work or power or energy from that particular source. Now, CI engine, compression ratio is very high. So engines is very large. Certainly the power output should be more. If the power output is more, if we need to, you can understand the power which is produced during power stroke, only a part of that power is utilized to run the for its operation. Remaining power or energy is stored in the flywheel. So for CI engines, the power produced is more. So essentially, to store a substantial part of that produced power, we need to have high flywheel or big size or large size flywheel. Yeah, so flywheel is used to control fluctuation of energy. That is why, because I told you that you need energy to 3 different strokes. So basically, if it is not available, then there will be a severe fluctuation of energy, and that is why the flywheel. So flywheel acts like a bank. I gave this example in the class even, that when we have excess money, we need to go to the bank. We deposit the money in the bank, and when we need money, we essentially go to bank and we withdraw money. So exactly, flywheel acts in the context of internal combustion engine like this. The excess energy is remaining stored in the flywheel, which is not in used or which is not used. As I told you, out of the total power being produced or available at this shaft, a substantial part is remaining stored in the flywheel, and that stored energy is again utilized to overcome or to execute 3 other idle strokes. So in this course, how can I get rank between 1 to 10? I really do not know, because you have to this is very I really do not find any essence of these questions in this forum. So what you need to do basically, not only for this course, for any course, if you need to get a good score or if you need to score good marks, you have to be very systematic. You have to understand everything. You have to read books. You have to perform well in all the class tests or quizzes. Then only it will help you to score a good rank. So I request all the students who are attending this session to write or to post your question in the chat box, so that we can take them off for a discussion. This live session is limited to only 1 hour. So I request all the students, learners who are attending this session to post your question in the chat box. In this course, Thermal Engineering Basic and Applied, there are many modules. So, in the very first module, we have discussed about basic of thermodynamics, and probably you have understood that is the most important, part to understand the operation as well as thermodynamic analysis of the applied devices or applied system. Muhammad Rahman is asking a question, why that work is not able to convert in mechanical energy instead of storing energy. See, that is the, there are 2 parts. That for 3, there are 4 strokes. So you have to execute all these strokes simultaneously. So you are getting power output from the power stroke, and the power which is being produced in the engine cylinder is not also available in the shaft, because shaft power is less than the power which is available inside the engine cylinder, that is the indicated power. So you know very well, because of frictional losses. Now, out of this shaft total shaft power, only a part of that power is available. Remaining power is is stored. Now, your question is no. Basically, engines are designed in such a way that the brake horsepower or brake power, that is the power which is available at the shaft, a substantial part of the power will remain stored in the flywheel, because we need to execute 3 idle stroke, in a continuous fashion. Again, asking a question. Yeah, fine. So I am telling you again, there is no any way to get good score except being sincere, hardworking, and you have to understand the subjects thoroughly. You have to read books thoroughly. You have to solve problems. And if I know correctly, in this platform, that is in MOOCs platform, it is not only the score that you should try to get, best in the final exam. So quizzes are also going to contribute some, important or some marks to be considered while final grading will be prepared. So you have to be systematic all throughout this course, and I hope if you are, then you will be having or you will be scoring good grade. That much I can tell you. So in this course, thermal engineering basic and applied, there are many modules. I am very much hopeful that, or I believe, you all will enjoy this course. Certainly, in the very first module, you have gone through the basics of thermodynamics, and that understanding will be very much needed to understand the thermal analysis of the system, thermal analysis of each and every component of a system. And if you only know the basics of thermodynamics, then only you will be able to understand the applied part. Can you know that how much amount of energy is stored in the flywheel? Certainly that will depend on the designer. So there is no any hard and fast, basically a rule, but whenever a designer is designing the engine, the designer must be knowing exactly, say for example, I can tell you. So this is again a very, intuitive question, I should say. So if you know what should be the load carrying capacity of a engine, and if you know the external load, and knowing that if you need to execute 4 different strokes simultaneously, so you can understand exactly fulfilling the amount of energy needed to overcome that load. You also have to have certain amount of energy to execute all these 3 strokes. You can design the engine. Adiabatic and polytropic equation detail. So again, I am telling you, adiabatic and polytropic equation in detail I have discussed in the class. Those classes are, I think those modules are available. Kindly go through them. If you have any specific question, kindly email me. I will get you back. Adiabatic and polytropic equations are also available in most of the thermodynamics, all thermodynamics books, undergraduate thermodynamic books. Kindly consult any standard book, you will get it. So, let me tell you one thing, that not heat and mass transfer surrounding, adiabatic process, that basically process is not going to have any heat interaction. That is true. But that certain amount of heat transfer will be there associated with mass transfer and vice versa. So adiabatic process, when you are going to have, so again I'm telling you, that no, I can tell you here for this particular course only, that if you when apply adiabatic process or flow process to be precise, then you have to have a control volume, and at a given instant of time you have to assume that the mass in the control volume is fixed. So certainly no heat is going to be interacted between system, that is control volume system, and surroundings in terms of heat and mass, no heat transfer, and also mass at a given time is remaining fixed. Yeah, you can get my email from the, I think course instructor details. You will be getting my email. No issue. So again, I'm telling this course, Thermal Engineering Basic and Applied, is an important course. Even if you are willing to join after your graduation or post-graduation to any industry, process industry, power plant industry, automobile industry, the basic understanding what you will be having after the completion of this course will certainly help you. In this course, we have discussed several modules, and so that is the very important modules, and these modules are important to know. That a few minutes back I gave an example. Say if you'd like to design, say for any thermal system, a thermal system will be having many components, and all components need to be functional or need to function efficiently to maximize the efficiency of the thermal system. So if all components need to function, need to operate efficiently, you have to understand, because essentially all components will be designed by a designer. So you need to know the process that will occur across through that device or through that component. And also if you know what should be the input, what should be the output that you are expecting from that particular component, then you need to know the thermodynamical aspects. Considering all this, no matter whether you are going to design any thermal system, say for example, in a power plant, if you have visited any power plant, then it will help you to understand, as I'm going to discuss today. There are many components. If we do not consider small components, at least there are 4 big components: boiler, turbine, condenser, and pump. So the efficiency of the power plant or efficiency of a power plant will certainly depend on the efficiency of each and individual component, like efficiency of pump, efficiency of boiler, efficiency of the turbine, and efficiency of the condenser. So we need to know specifically the process that is taking place across the pump, whether it is an adiabatic process or it is an isothermal process. And also knowing the process that is going to take place across a particular device, we also need to optimize. If we really do not know the thermodynamical aspects of the process, if we really do not know which law we should apply across that process or to describe the process, it won't be possible to design the device. So I am expecting and I am hopeful that after completion of this course, or the understanding that you will gather from this course will certainly help you to know many subtle things, many thermodynamical aspects, many processes which are very much needed for any process plant, power plant, automobile industry, refrigeration system, etc. So I request the audience participants of this session, at least those who are attending the session, kindly post your question in the chat box so that we can discuss, because the session is limited to only 1 hour. Even if the session is, I can tell you, if it is not possible for you to post your question in the chat box, at least those who didn't join the session, I request you all to post your question in the discussion forum. You also can email me so that I will try my best to get you back with the solution, with the answer to those questions. The course Thermal Engineering Basic and Applied is a very important applied course. It is a core course. The course is designed in such a way that it will help you to understand several processes of thermal engineering applications. Once you complete this course, it will certainly help you to get to know several conceptual understandings, several conceptual issues related to applied thermodynamics. I once again request to the students, learners of this particular course and those who are attending this session to post your question in the chat box so that we can take up those questions for a discussion. If we have no more question, then we shall wrap up the session for today, and again we shall assemble in the next live session to have a further discussion. As I told you that it is not mandatory that you have to have questions and only the questions will be discussed in this live session only. The essence of the session is to have some direct interaction with the instructor. But still, if you have any questions in between, kindly post them question in the discussion forum. You can email those questions to me even. I'll be happy to give answer to those questions. I think there is no more question in this forum. And if we have no more question, I hope we can wrap up the session for today. And I sincerely thank you all the students, learners who have joined this course, and we will assemble again in the next live session to discuss, to have further discussion. I'm pretty sure that you'll be having many more questions from the remaining module of this course. So with this, I stop here today. I wish you all the best. Thank you.